Okay, we'll move on to math. We're ready to start up on page 503. Everybody have that out?
Yep.
Okay. So study the example showing how to find equivalent fractions, then solve problems 1 through 8. So the example is Maria colors 1/3 of her art paper red, which they show over there. Erica colors 2/6 of her art paper green, which is down here. The papers are the same size. Do the two girls color the same amount of their art papers? Look at the amount colored in. Is it the same amount? Yes. Okay, and then if we look at the number line, the top is split into thirds, like Maria's, and the bottom is split into the sixths, like Erica's. So 1/3 is equal to 2/6. So that means they are equivalent. The girls color the same amount of their art papers. All right, now let's look at this number line. We're going to use this number line to help us answer questions 1, 2, and 3. All right, so find 1/4 on the number line. Point to it. Look right underneath it. Do you see the equivalent fraction?
Yes.
Complete that fraction right there for number 1. Okay, now on that same number line, find 6/8. Do you see 6/8?
Yes.
Look above. Is there an equivalent fraction?
Yes.
Write that fraction down. The last one we're going to do is find 2/4. Do you see the equivalent fraction?
Yes.
Write that down. Got it? Okay, let's flip our papers over. All right, we're going to shade the models to show equivalent fractions in problems 4 and 5. Then fill in the blanks to write those equivalent fractions. Are these the same size?
Yes.
Are they the same shape?
Yes.
Yeah, they're just split into different parts, aren't they? Okay, so this first one, we need to shade 1/2. So how many parts will you color in of this one? 1. Now, next door over here, we need to make it equivalent. So if we did 1/2 of this, how many, don't say anything out loud, how many of these shapes do we need to color in to make it the same amount as 1/2? Just one of those?
No.
How many would make it exactly the same amount colored in? Everybody.
4.
Show me that and then write the fraction. Got it? Okay, look at 5. This is telling you need to color how much of it? 2/3. Do that right now. Now, to show 2/3, showing the same exact amount colored in, how many do you need to color over on this rectangle? color it in so that it has the same amount colored on both sides, on both rectangles. And then write the fraction for what you colored on that side. Is everybody ready for 6? All right. On 6, it says, well, 6 and 7, it says, draw lines and shade to show equivalent fractions in problems 6 and 7. Then we're going to fill in the blanks to write those equivalent fractions. All right, so we need to show that this rectangle gets split into how many equal parts? No, how many equal parts? How many equal parts though? 2 equal parts. So let's do that. Split your rectangle in half. 2 equal parts. Before we do anything, let's go next door. How many equal parts will this one need to be split into? 4. So let's split it into 4. Now, there's more than one right way to do this. Could I do here, lines here and here?
Yes.
Could I do a line across?
Yes.
You do the way that you want to create fourths. Okay, now, this tells me I have to shade in, how many parts do we shade in? 1 part. So let's do that. Okay, to make this one equivalent, equal to the same amount shaded, how many parts would I need to shade in over there? So that it's the same amount as that one. It has to be equal to it. Jenny? Do you agree with her?
Yes.
If we color in this 1 and this 2, is that the same on both sides? Yes. So what's our fraction going to be over here? How many fourths? 2 fourths. Okay, let's move on to 7. We have to divide this shape into how many equal parts? 6. And this shape into how many equal parts? 3. All right, so I think I'm going to split both of them into 3 equal parts first. As close as I can. But this one has to be split into 6. What could I do to get my 6 equal parts on this shape that I only have split into 3 parts so far? Lucas, come show us. That's what I was thinking too. Anybody else think that works okay? All right. So on this shape, how many parts do we have to shade in? How many? 4. So I'm going to do 1, 2, 3, 4. Keep them together, remember? To make it equivalent, the same amount colored in. How many parts of this rectangle do I need to color in to make it equal to this one? How many parts do I have to color in over here? Just one?
No.
2, 3? What should it be? Raylyn? Agree? If you didn't hear her, she said 2. I agree with her. So 1, 2. Notice how I'm always coloring on the same side of my rectangle. It's easier for my mind and my eyes to see that comparison of the two, to know that they're the same amount. So what are we going to write to complete this fraction on number 7? How many thirds?
2.
2 thirds. I think that they're going to trick you on 8. What is a fraction equivalent to 4/4? So think about this. If you have 4/4, what does that equal? Remember on our number lines when we would see that? What does 4/4 equal? Or it could be 3/3, or 6/6, or 8/8, or 10/10. What do they all equal, Reese? They equal 1 whole.
Isn't there a fraction way to write that?
No, it would just be the 1 whole. This is the fraction that is 1 whole. They've said, right, what is a fraction equivalent to 4/4? So what's another fraction that would be equivalent to 4/4 then? 2 halves, 3/3, 5/5, 6/6. Are those all equivalent to 4/4? Yes, because they all equal what?
1 whole.
Okay. All right, so moving on to page 505. Okay, it says to read and try to solve the problem below. Casey uses 2 boards of the same size to build a birdhouse. He cuts each board into fourths. What does fourths mean? How many is that?
4.
4, right? 4 equal parts. How can you write the number 2 as a fraction to find how many fourths Casey cuts the boards into? Does that make sense to you? Let's jump over here. Flip your paper. Okay, so you can use models to help you solve that. So he has 2 boards, right? So what they did is they made fraction bars to show those 2 holes. There's 1 whole board here, and there's 1 whole board here. So that's the 2 holes. Each board is divided into
4.
fourths. So 4 equal parts. 1/4, 1/4, 1/4, 1/4. Those are the unit fractions, right? But all together we would say this is 1/4, 2/4, 3/4, 4/4. Okay, so there are 8 1/4 in all. 1, 2, 3, 4, 5, 6, 7, 8. You could also create a number line to help you with this. So since they are both 1/4, you would go 0, 1 whole, 2 wholes. Why 2 wholes? Why 2 whole numbers? Natalia?
Because 4/4 is 1 whole, and then 8/4 would be another.
Exactly. Because we have to show 2 wholes, because how many boards are there?
2.
2 boards, right? So 1/4, 2/4, 3/4, 4/4 equals that first board, the 1 whole. 5/4, 6/4, 7/4, 8/4 is equal to 2, because that was the second board. Okay, but notice our denominators are all what? 4, because each one was split into 4 parts. All right, we're going to jump ahead. Let's look at page 508. All right, now, how many triangles are there here?
3.
There are 3, right? So what would be a fraction that would be equivalent to 3 wholes? This would be, how many parts are in this whole?
2.
So this would be 1/2, right? This would be 1/2. But if I were counting them, what would it turn into? So this would be 1/2, this would be 2 halves. This would be how many halves?
3 halves.
How many halves?
4 halves.
How many halves now?
5 halves.
Oops, I don't know why I wrote 6. I was counting ahead. 5 halves. And then this one would be,
6 halves.
so 6 divided by 2 equals, or 2 times what equals 6? Think of it that way. You should end up with that, right? 6 halves equals 3. Does that make sense to you? No? Okay, maybe it'll make more sense on a number line. Let's take a look at this number line together. All right, Louisa has 2 ribbons. So here's her first ribbon, right? And here's her second ribbon. They're the same length. She cuts each one into
8.
eighths, which means 8, right? 8 equal parts. Use the number line below to help you write the number 2 as a fraction to show how many eighths she cuts the ribbon into. So let's just count across. Jenny, are you with us? Okay, this first one would be what? 1 what?
8.
Eighth. What's the next one?
2 8.
Then?
3 8.
Next?
4 8.
After that?
5 8.
Okay, keep counting that across. You keep writing those. Once you get to 8 eighths, what's next? 9 eighths, and keep going. Once you get across to 2, Do you see that equivalent fraction? So we're using the number line to write the number 2 as a fraction. So what is the fraction that is equivalent to 2 on this number line? 16 eighths. 16 eighths equals what? 2. Write that down on your solution line.
That makes more sense.
Does the number line help it be a better picture for you? Who thinks they can figure out what the fraction would be for 3 wholes? If 8 eighths was 1 whole, 16 eighths was 2 wholes. There's a pattern to it. It's like you're skip counting by eighths, right? 8, 16, because 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is, if you know your multiplication facts, man, this makes it a lot easier. It would be what, everybody?
24.
Okay. All right, now it says to draw a model to show 3. So how many whole numbers are going to be on this model? 3. I say let's do a number line.
Yeah.
Okay, I'm going to, is everybody done with this? I'm going to clear it so that I can move this up and make it bigger. Okay, so we need a number line that has 3 holes on it. So we always start with what digit over here?
0.
0. We're going to end with what? 3. So what whole numbers are going to go in between?
1 and 2.
1 and 2. So I need to do my best. Oh, I'm going to put my whole numbers across the top. I think that'll be better. And then I'll do my fractions underneath. So I'm going to have 1, 2, and 3.
It's like splitting the number line into thirds.
Exactly, splitting it in thirds. Okay. This tells me how many equal parts need to go in between each whole number. The denominator does. How many equal parts are we breaking each section up into? 6 parts. Do that on your number line. Okay, everybody have that? 6 equal parts between each whole number. And then I want you to label each one of those marks that we made, those sixths, label those as those individual fractions. Remember how we did this before? And we keep counting across. Keep doing that on your number line. Sounds like they hit something with the mower. Okay, now let's take a look at this. So we have all of our sixths labeled up through our whole number 3. You didn't have to do this, but notice how I made the 1 hole, the 2 holes, and the 3 holes. Notice how I made those fractions a little bigger. I did that for you to be able to see this pattern. Skip counting by 6s. If we skip count by 6 one time, we have 6. If we skip count 2 times, we have 12. If we skip count by 6 3 times, we have 18. What if I said, what would the fraction be for 4 holes? So 6, 12, 18. What would the next one be, everybody? 24 sixths. What would 5 holes be on this then? If we had 5 over here, it would be how many sixths?
32. 30.
30. Because 6 times 5 is 30. All right. So we just drew a model that showed that 3 equals 18 sixths. That's probably a good stopping point for today. So the papers that we completed together, hold on, are you listening?
Yes.
They're going to go in your mailbox in just a minute. The papers we have not done yet, where are they going to go? In your folder.
Are we going to do this backside too?
The backside of page 508. No, that was the backside.
Oh.
We skipped that side. So you can just take it home. So we're going to be starting with page 509. You confused me, Connor.
Stuck in my head.
Oh, did
I
you?
was thinking 8 times 4.